Dear students, how are you? Hopefully you all are doing well. This is Amit Shah, lecturer, Department of Mathematics, Milestone College. Today we are going to discuss about differentiation. Especially we are talk about chapter 9b, that is your differentiation using the first principle rule. This math is very important for your all types of exam. So be concentrate in these classes very attentively. Let's have a look our today's class. So dear students, according to our lesson plan, today our discussion topic is differentiation, and today especially we are talk about exercise 9b. First of all, I wanted to talk about a definition, and the definition is derivative as limit. What's the differentiation definition of it? The definition of derivative as limit is looks like this, that if y equal f of x, if y equal to f of x, that means if y is a function of x, then what we can write? Okay, if y is a function of x, then what we can write? Limit s tends to 0, f of x plus s minus f of x divided by s. Limit f of x plus f of x plus s minus f of x divided by s is called the derivative of f of x, is called the what is called the derivatives of f of x. That is what we can write actually. That is, if we differentiate f of x, that is differentiate with respect to x, you can also write it is called derivative of f of x with respect to x, with respect to x. So if we differentiate the part of f of x, then we can write limit s tends to 0, f of x plus s minus f of x divided by s. So dear students, we can write this according to our definition. Okay, and this definition will be used in the differentiation when we will use the first principle. So by using the first principle, if we are talking about, or if we are trying to focus on find out some values, say for example sine x, ln x, then e to the power x, a to the power x, even x to the power n, all can be solved by this way, and this actually known as the first principle rules. Okay, let's have a look some example using first principle. We can find out some derivative. Okay, so dear students, this is our first problem, and the question says derivative of x to the power n using first principle law. We have to derivative x to the power n. How we can go for it? Okay, the solution should be like this. Let f of x equal x to the power n, then f of x plus s, x plus s whole to the power n. I think you all know that if something is given, say for example that f of x equal, say for example x, then f of, say for example ant should be ant. If here is n, then it should be ant. If here is n000, then it should be n000. Main fact is just sense the part of x with respect to x. At the place of x, here was just situated at ant. Here similarly, here was x, here was x plus s. That's why we have written here x plus s. Okay, so that was the function of x, but here it is function of x plus a's. My dear students, maybe one question arises in your mind, why we are finding f of x or f of x plus a's? Because we have a formula according to the first principle law. According to first principle law, we have a formula we know, and the formula is what? Can you tell me? Exactly, ddx of f of x should be limit h tends to 0 f of x plus h minus f of x divided by h. Yes, students, that is why we have found x plus x and f of x. Just putting the value in here first. So if we are putting the value of these two, then we can write limit h tends to 0 f of x plus h is x plus h whole to the power n minus x to the power n divided by n. Then what thing we can write? Here, assumption we are going for that first. Let us assume that our x plus a is, say for example, y. Okay, if x plus h is y, then what we can write actually? Limit h tends to 0, here is y to the power n, minus here is x. So what can be written as a, at the place of x? At the place of x we can write y minus h. So we can write here y minus h to the power n. Okay, so this can be written. At the same way, we can write another thing, that here if we are trying to focus on finding the value of h, then what we can write? It should be y minus x. So here we are going for y minus x. My dear students, we have found something from this assumption. From this assumption we can find these two values, but if we observe it very clearly, here is y, here is y minus x. So if we are not changing up to this part, then what we can write? If we not change it, that is y to the power n minus x to the power n divided by y minus h. Here what we can write? Here obviously our h should be changed, it should be y tends to x, y tends to x, because y should be equals to tens. If it like this, then we know a formula. What is that formula? We have a formula we know already, that is ddx of x to the power n, ddx of x to the power n minus a to the power n divided by x minus a should be n into x to the power n minus 1, n into x to the power n minus. So here n into a to the power n minus 1. So another thing maybe arises in your mind, why we have changed it. H tends to 0 is y tends to x. Okay, dear students, look at the board here. If x plus h is equals to y, and if h is 0, then x should be equal to y. That means x is tends to y. Clear? That means y is tends to x. That's why we have written it here. Now, according to our this formula, we can write n x to the power n minus 1, and that's the solution of our this. Okay, that means ddx of f of x was x to the power n. So ddx of x to the power n is this. So what we have found, we can write in the very final line that differentiation of x to the power n equals to n into x to the power n minus 1. Maybe we have memorized this formula already, but this is the first principle law, or this is the formula we have found by using first principle law. So it's very important. Okay, let's have a look our next math. Okay, dear students, here we have observed that derivative of e to the power x using first principle law. That's the question number 2. So similarly, since we have talked about first principle law, we have to write the first procedures at the same way. That is, we have to find f of x, then f of x plus a's, and then we have to go for the formula. Okay, write it down. Let our f of function of x is e to the power x, f of x plus h is e to the power x plus h. We know from first principle law that is limit h tends to 0, f of x plus h minus f of x divided by h, where ddx of f of x. Okay, we have known all of this part. Just putting down. So here ddx of f of x equal e to the power x is equals to limit h tends to 0, f of x plus h, that is e to the power x plus h, minus f of x, that is e to the power x divided by h. Clear, dear students? My dear students, you have already known that x will be replaced by the others part. So here was x, here was again x, and here was x plus h, here was also x plus h. So here what we can write, limit h tends to 0, e to the power x into e to the power h minus e to the power x divided by h. Limit h tends to 0, e to the power x, if we take it as common, then we'll get e to the power h minus 1 divided by h. Okay, so if we take e to the power x at the very first place, I mean before the limit part, then what we can write, e to the power h minus 1 by h. Why we have taken e to the power x at the very, I mean the first part or the before of the limit part? Why? Because this limit will work only the h position, not the others. That's why these are the actually working as the constant part. That's why e to the power x can be come at the in front of the limit. Okay, now so e to the power x, if h is goes there, then it will be e to the power 0 minus 1 divided by h. But we have a formula. We have a formula. What is the formula? And that is limit is, now it will be x tends to 0, e to the power x minus 1 by x. If anything like this, that should be equal to 1. That should be equal to 1. Okay, so here is. So we can say the value of it is definitely 1. So we can write e to the power x into 1, that is e to the power x. What we have been actually found here? We have found a very simple thing, that is ddx of e to the power x is equals to e to the power x. ddx of e to the power x equals to e power x. Okay, so let's have a look our next math. So dear students, that is our next problem, that is derivative of a to the power x using the first principle law. What we have to do? You have already known f of x plus h, first principle rule, then going the usual procedure. Okay, here let us assume that f of x equal a power x. So what will be f of x plus h? X should be changed at x plus h, and what we know from the definition of the first principle law, we know from the definition of first principle law what ddx of f of x equal limit h tends to 0 f of x plus h minus f of x divided by h. Just putting the value of it here, ddx of f of x, that is a to the power x, limit h tends to 0 a to the power x plus h minus a to the power x divided by h. Yes, you have already known that a to the power x plus h can be written as a to the power x into exactly limit h tends to 0 a to the power x and a to the power h minus a to the power x divided by h. So if we take common a to the power x, then what we can write? Limit h tends to 0 a to the power h minus 1 divided by h. And obviously a to the power x come in front of limit part. A to the power x limit h tends to 0 a to the power h minus 1 by h. Dear students, we have a formula, we know a formula, that is limit x tends to 0 e to the power x minus 1 by x equal to 1. If it was e, then that will be the perfect thing, but since here is given a, that's why we can't go. But we have a way what we can write this as e to the power ln, e power ln. Actually when we write e power ln, then it actually represents 1 into a power h minus 1 divided by h. Okay, now what thing we can write from here? Have you any idea? Exactly, here we can write h should become at front because h is the power, so it can become in front of the ln or log. Okay, so we can write e power h into ln a. Wait, it should be ln a minus 1 divided by h. We know that the formula of e to the power x minus 1 by x, isn't it? But here one problem arises, that is here is h. If this part and this part are same, then we can write it as what? Exactly, we can write it as 1. So we'll write here was h ln a into ln a, because we know a formula. Which formula we know? We know a formula, that is limit h tends to 0 e to the power h minus 1 divided by h is equals to 1. It can be also x tends to 0 e to the power x, here is x equals to 1. So here it has been, it should be the same, the power of e, and here that two places must be the same part. That's why we have matching it by multiplying ln a, and here we have taken the ln a multiplication, so that these two will be cutting down and it will be remain the same. So what we can write here? We can write this part actually gives 1. So a to the power x into 1 into ln a to the power x into that into ln a. So finally we'll get a power x into ln a. So what we have been found? Actually we have found ddx of a to the power x equals to a to the power x into ln a. But at the case of ddx of e to the power x, that was only e to the power x. But since here is a to the power x, that's why it is a to the power x into ln a. Clear, dear students? Okay, let's have a look our next math. So dear students, that is our last part of this lecture. Actually we have 6 trigonometric ratios, but we'll working with one. Okay, so derivative of sine x using the first principle law. How we can go for it? I think you can understand these types of math very easily, isn't it? Okay, let's have a look. First, let f of x should be sine x and f of x plus 8 must be exactly sine x plus s. And we know from the definition of first principle law, from the definition of first principle law, what we know actually, d dx of f of x equal limit h tends to 0 f of x plus h minus f of x divided by s. Okay, now just putting the value up in here. If we put here the value of f of x, then it should be sine x, that is d dx of sine x should be limit h tends to 0 f of x plus h is sine x plus h minus sine of x divided by h. Okay, dear students, here we have a formula actually, that is sine c minus sine d. Many of you have make a question that, sir, why we are going for the formula of the trigonometry and then we move on to this differentiation part? Because trigonometry is very much important, especially the formula is very much important at the case of differentiation. That's why we have learned you how to actually go with the trigonometric formula. Then here you can understand very easily that sine c minus sine d, what's the formula of it? That must be what? That must be 2 cos c plus d by 2 into sine c minus d by 2, and here is then limit h tends to 0, it can be 2 cos twice x plus h by 2, and here sine h by 2 divided by h. Now here we can write a fact, that is limit h tends to 0 cos of twice x plus h by 2 into sine h by 2 divided by h by 2. Actually these two has what going here, that is h by 2. So if we sensed or make the limit separated, then we can write cos twice x plus h by 2 and limit h by 2 tends to 0, then sine h by 2 divided by h by 2. Maybe one question arises in your mind, sir, here was h tends to 0, why you have written h by 2 tends to 0? If h tends to 0, that means if the value of h is 0, you obviously know h by 2 is also 0. That's why limit h by 2 tends to 0 into h by 2, I mean sine h by 2 into h by 2, and you know this is 1. Why? Because sine, we have a formula, sine x tends to 0, sine x by x is 1 from that. And here if we putting the value of h in here, then we can write cos 2x by 2 into 1. So we have found cos x. I mean 2x plus 0, so 2x by 2. So what we have been found finally, ddx of sine x is equals to cos x. So dear students, that's all for our today's lecture. If you have any question, don't hesitate to ask me or call me anytime in any places. Thank you very much. Stay with your study. Thank you very much. That's all.